Hello, my name is Eric Grigori, and this is a breadboard connected to the, I think it's pronounced Canakit, C-A-N-A kit. Okay, so this right here is the 40-pin header, and that's basically a I/O header for the Raspberry Pi. What you want to do is take your kit here. Now notice I've got this plugged in already, but there's a little index right here. Okay, there's a little cutout, and on the cable there's a little extra piece of plastic. So this will only go in this way. So you want to connect that up like that. Plug it in. Make sure the index here, you can see the index, see it's plugged in right. And then on a Raspberry Pi side, and this is very important, you need to make sure that you do not skip a pin. This has to be plugged in. And it's very easy to plug this in incorrectly and miss a pin. Now remember, if you got any rings on or anything, be careful when you're holding the board. And what you want to do is you just want to verify that you're not missing a pin, that it's not offset. I don't know if this camera will focus, but you want to make sure that you're not offset at all. Okay? And that there's no pins being exposed on either side. And then plug that in. And when it's plugged in correctly, you should see that it's centered, plugged in. So now what you have is basically what this does is it just translates these pins into this header here to make it easier to plug into a breadboard or to debug. You could just as easily connect directly to these pins here, but this makes it a little simpler. And then just the kit comes with this little card here that describes what all the pins do. But that description's also right here. Now, one of the things to take note, and I noticed this, I don't normally use this thing. I normally just plug right in, but you got to be careful with how this is worded. So the way this is printed, they didn't have enough room to print the pin ID for each pin. So it's sort of offset. So the way this works is there's a top and a bottom, and it's every other pin. So you just need to be careful when you're connecting to it, that you're paying really close attention to what pin you're connecting to. Raspberry Pi adapter. And you have a resistor and an LED. Now the resistor is not polarized, which means you can connect it in either direction and it doesn't matter. The LED, on the other hand, is polarized. And you'll notice that one leg is slightly longer than the other. You'll also notice, and I'll include a picture, that there's a flat edge on the LED. Those are indicators of polarity. And the flat edge indicates negative or ground. So the shorter LED, the shorter leg here, and the flat edge indicates ground. Now here's a breadboard. Now what's really important with breadboards is to understand that these markings on the breadboard, these, I guess you call them row columns, whatever you want to call them, these markings are not consistent. There's no standardization there, so there's no consistency. So it's very possible that, let's see it over here. Yeah, these markings here, none of those markings are standard on breadboards. So there's going to be no consistency. So if you received a breadboard that does not have these markings, or the markings are reversed, that's not a problem. So if you received a breadboard where the markings are reversed, or the markings aren't on the board at all, that's not a bad breadboard. They're not standardized, so that's to be expected. Now, these pins here, each one of these solder connections up here are soldered to a pin that goes into the breadboard. Okay, all the breadboard is a bunch of wires with these being connected this way. So this pin here is connected to this pin here. So this pin here is connected to this pin here. These holes are all connected like this. And over here, it goes like this. So all these holes are connected. So my negative here, my negative 3 volts, is available on any one of these holes. Now this is really important. This particular breadboard is split. And that's what the purpose of these wires are. So these wires connect these two sides of the breadboard. These are actually basically two breadboards connected together. Not all breadboards need these wires, but if you do not have these wires in, then this side of the breadboard will not have your power. So you got negative here, so it goes through all these connection points, this whole, okay, and you got positive over here, which goes through all these connection points. But on this side of the breadboard, there's no connection in the breadboard. I had to add these wires in order to connect them. That is probably one of the biggest problems students run into because, again, breadboards are non-standard. You may have a breadboard that requires the connections, or you may not. The only way to know is actually to test the continuity. What you're better off doing is whatever breadboard you have, just stay on this half. You know, use these connections over here closest to the Pi for your ground and positive, and for your 3.3 volt ground and positive. As long as you stay, you know, to this side, you know for a fact that these are all connected and you don't have to worry about this. Now you'll notice that these pins are all marked. Okay, there's these markings on here. That's what you want to use when wiring the breadboard. Don't use the rows and the columns. I know those are provided in the instructions, but they're just, again, since there's no standardization, it can be more confusing than helpful. What you really want to do is you really want to follow the instructions that say connect this GPIO signal to the resistor, or connect this GPIO signal to the LED, or connect this GPIO signal to the LCD in the future. So what you want to do is you want to look at the point A to point B. So what is an electrical circuit? An electrical circuit is just a connection from point A to point B. What you want to do is you want to take note from the instructions on what point A is. So is it the GPIO? Is it a signal? Is it whatever on here? And what is point B, which is whatever you're connecting to. Again, in the future, there's switches, LCDs, LED resistors, whatever. So the point is to concentrate on the point A, point B, as opposed to concentrating on the row column. Forget about the row column. Now, how do you know what, let's say here is, I think this is GPIO 21. So how do you know, if you want to connect to GPIO, how do you know where it's connected? Well, this gets a little complicated. And it gets complicated because of point of view. What you need to do is you need to look, if you look straight down, it needs to be straight down, then this pin, you can tell, connects to this line of breadboards sockets. Okay. The problem is if you look at it from an angle, it can be confusing. So a lot of times what I'll do is I'll actually lift this up a little bit. And if you look closely, I'm not sure if this is going to come out on the camera or not. I'll take a picture though. But you can actually see that from the solder point up here, you can see the pin, and you can see the pin going into the breadboard. So I can tell absolutely that this pin here goes to these lines on the breadboard. And then what I would do is I would suggest actually marking your breadboard. So I would suggest putting a little, once you plug this in, put a little marker here. A little, just use a little marker. Put some mark here so you know that this pin connects to this row. Because where it gets confusing is, again, if you're looking at it from the side, the parallax causes it to look, it looks like it's offset. So it's very important that when you're looking at this, you're looking at it from the top down. And that's actually why I have the camera set up this way. Because hopefully, hopefully it's obvious. It looks like it is. So the biggest issue by far is because students are using the row and columns. If you plug this in and you offset it a little bit by one pin, all those rows and columns get thrown off and won't work. That is probably, that and this connector and the same connector that's inside the Pi. Those two issues are 99% of the problems that students have, because they think they're plugging in, they're using the row and columns, so they think they're plugging into the right socket here, when in fact, because they've offset this in the initial instructions, they're not plugging into the correct place. Let's say you want to connect the LED circuit. Okay, how do you do that? So remember, the short side here is ground. Okay, we have 3.34 ground over here. We have the short side here. So we're going to connect that to ground. And I can feel that the flat side is over here. So this leg of the LED is connected to ground. So you have ground here, it flows through these sockets, and we plug in right here. So now this side of the LED is connected to these sockets. So we're going to put the resistor in there. Now keep in mind, your circuit may be reversed. You may actually be connecting the LED to positive. It's called source or sink. I'm just showing an example of source. So what's happening here is the GPIO pin is going to provide the positive volt, that's an incorrect term, but the positive voltage to the LED, and the negative here is going to be the negative side. Your circuit may be reversed, where you plug in, well, I'll show you that circuit in a second. Okay, so now let's go ahead and take a look at this. Now we need to connect the Raspberry Pi to the resistor, and I'm just going to use GPIO 21 here. Okay, so I'm going to actually put this in over here. So GPIO 21, and then I'm going to plug that into here, because that's the same, that's the common socket with that side of the resistor. And there you go, that's my circuit. Now this is what's called a source side circuit, because what's happening is the GPIO is sourcing the current. It's the positive side of the LED. So now let's do a traditional a sink side. And there's electrical reasons why you do one or the other. I'm just showing them for consistency. So the way you would normally do a sink side is you're going to add resistor here. Now I need to reverse the LED in this case. Okay, so again, the short side of the LED goes to the negative part of the circuit, and the long side goes to the positive side of the circuit. So in this case, the negative, or ground, is going to be supplied by the GPIO. You can see how that connects right there. It goes to the GPIO. And now in this case, the positive side is going to be connected here. So you have this side, which is the long side, connected to a resistor, and the resistor now goes to the positive side over here, which connects to all these sockets, which goes over here. And that's how you wire up the LED circuit. It's one way or the other, depending on whether it's a source side or sink side, and that'll be available in your instructions. Now, future circuits are the same thing. Concentrate on the pins as opposed to the XY coordinates. Okay, so there's two switches. This switch here came with the Canakit. Yeah, it came, let's see, in this bag here. The problem with this switch is it doesn't, the pins aren't long enough to fit into the breadboard correctly. So I had a hard time getting this switch to work. So this switch came in here, and you'll notice that it's got longer pins. This seemed to work better with the breadboard, so I'm going to go ahead and plug this in. Yeah, let's just get this plugged in. doesn't go in there very well. It's not the best. Okay, so what I'm going to do is I'm just using the Raspberry Pi as a power supply. There's no software running on it or anything. So notice that this resistor is connected to my 3 volts. Let's see, do I have my over here? Let's use this. So this resistor is connected to my 3 volts, positive right here. Okay, goes to the LED. And now what I'm going to do is I'm going to take one side of the button and I'm going to connect it to ground. Okay, so this ground here, this negative here, and this negative here are the same. They're both ground. And then I'm going to take this side of the switch, which is over here. So that's this pin and this pin. And I'm going to wire it to the diode. Okay. Now this would be, I don't know if you can see it, but there's the flat part of the diode right there. So there's the flat part of the diode is right here. So this is the ground side. This is going to be the short pin. So now if I push the button, the LED comes on. So what's happening when I push the button is it's making an electrical connection from this pin here to this pin here. Okay. So when wiring the switch, just keep in mind that these are the two sides. Now they both should be equal. So this side is the same way. When you push the button, these two pins are connected. Now watch what happens if I take my LED and put it in backwards. So now I've got the long side towards ground and the short side over here to the positive 3 volts. Now when I push the button, it doesn't work. So remember, your LED is polarized. The long side has to go towards the positive voltage, and the short side with the flat edge there needs to go to ground. And you need a resistor in series with the LED, or you will fry the LED, or worse yet, you'll fry the GPIO port on your Raspberry Pi. And yes, fry is a technical term. Now, with this little simple circuit here, you know, this is a very helpful way of debugging. So what this is a extremely simple logic analyzer. So if with this circuit, remember, this side is connected to positive. If I connect this to ground, the LED turns on. So let's say here, so this is ground right here. And if I connect this to ground, the LED turns on. Whereas if I connect this to, anyway, I'm going to stick with that. So if I connect it to ground, the LED turns on. So if you want to test your circuit board, so let me just show you this. So let's say over here, that's ground. So now if I pull out this little jumper here, like I was saying earlier in the video, see, it doesn't work. So these jumpers on my particular breadboard, these jumpers have to be in place. So this is just a good, very, very, very simple logic analyzer that can let you poke around the circuit and determine if you've got wires connected correctly. It's just a little quick debugging tool.